world of work.
The world of work.
The opportunity for men and women
to put their skills to work in satisfying careers contributes to the quality of life for all people.
The dignity of work has always been part of the American story.
Classrooms that connect learning with real work experiences
give students the opportunity to explore vibrant career fields
and define areas of interest in which they can make an impact in the real world.
In the real world.
In the real world.
You want to feel like you've made a difference. I think that's a fundamental human need.
In a working class, history provides clues for solving present-day challenges.
Math explains the mystery behind technology.
We need individuals with strong math and science skills. We need individuals that can operate in a team. And we need individuals with technical skills.
And lessons in communication.
And help us to work together to build rich and rewarding lives.
Rich and rewarding lives.
Rich and rewarding lives.
People who make things are necessary.
Students and faculty
find passion and purpose
where real lives intersect.
Where real lives intersect.
In a real working class.
In a real working class.
Working class.
Working class.
Working class.
Working class.
That second those lights flash, it's a little bit of, here we go again, oh my gosh, it's gonna happen.
This process of working through something and analyzing is gonna be a skill that you're gonna need forever.
That cultural thing of like females aren't doing engineering, they aren't doing mathematics, it's to me it's just ridiculous.
Just looking around, look at your clothing, look at everything that you touch on a daily basis. Someone is making these products. Robots have kind of taken place of the unskilled labor, but we still need the skilled technicians.
So we're making our slime.
As I look back, I think I like the scientists who were trying to stretch the ideas of their day.
Students learn by doing, and the science side of things, there's so much they can do. So I'm Dr. David Richards, and I'm a physics professor at Penn College, and I also teach astronomy in a course called the Science of Spaceflight. When you're designing and building a robot or any type of machine, the physics is crucial because it explains the torque and the work and the energy and the power and the electrical. So it combines all those ideas into one. They recently had a robotics competition on campus here, and I took my kids because they thought it was awesome to see these robots battling each other and sparks flying. And it was interesting as I watched because you could see a lot of physics, the low center of gravity and a simple lever and just a ramp, to be able to flip something up and spinning objects. I mean, if you look at the technology that's involved with the robot, it's all based on basic fundamental principles of motion, force, torque, and energy. And so you can't touch something without it touching you, right? That's Newton's third law. And those things are in constant contact and trying to fling them and trying to break them. And so, yeah, you're in constant action and reaction mode with the battle bots. I mean, it's a great summary of Newton's 3 laws of force and motion and inertia. It brings all those ideas into one. And so you can make a prediction on how it should work, but other people are trying to do the same. So it's interesting when they battle because you want to see whose design is going to work the best. Science is built upon a foundation of other people's work and their experiments, and you have to be able to repeat the experiment, you have to be able to verify it and validate the experiment. And that's the power of science, because you can rely on other people's work and you can repeat it. And the history behind that is very fascinating, learning the people that came up with the first experiment on finding the electron charge, or the scientists behind them and their life and time is amazing. It brings it all together. It brings the practical theory along with the people that discovered it and how they discovered it into a bigger theory or a law eventually. Wernher von Braun, who was a famous rocket scientist, when he was a child, he said, I wanted to learn how rockets work, but when he went to the books, it was all math and physics, and he went to his teacher and said, look, I need to know how this works, and he was only in 7th or 8th grade. And students do the same. I have students that are always trying to connect the dots and figure out how the physics relates to their major. Physics is built upon kind of a hierarchy of knowledge, so you have to understand forces to understand work, and you have to understand work to understand energy, and you have to understand energy to understand power. And so you have to start off with basics, and sometimes you want to jump in with the most interesting stuff, the quantum physics and that thing, to really get the students interested. But at the same time, you can't just jump into something without giving them a fundamental, basic understanding of the terms that you're going to use and how it all comes together. Physics is the study of the natural world. It studies how nature works without getting into the living things, living organisms. And it goes to the basic idea of what is the observable universe? How do we know what is out there? And it's not just hypothetical or theoretical constructs of your own opinion. It's based on data and analysis and other people's findings. And so it gets to the core of how people should think about how nature works and not just what they feel. There's basically two things in nature, matter and energy. And so matter is the substance and energy is the driver of that substance. And so physics looks at how those two things interact. And what is matter? Well, matter is the substance that makes up everything. I mean, if you look at the world around you, what is it made of? If you break an object in half and then in half again and half again, is there a limit to how far you can break it down into smaller and smaller pieces? And energy is this nebulous thing that's hard for people to grasp. You can't create or destroy energy. It's always transformed from one form to another to another. So we don't really lose it, it's just converted. There are many people that have tried to invent machines that will give you more work out than you put into it. But it turns out that if you go to this fundamental law, it'll save you a lot of time later, because as far as we know at this point, energy is conserved. You just can transform it, but you can't create or destroy it. And it's that kind of constant transformation of matter and energy that gives us the ability to control it, but also to understand how it all works.
What's the most fun part of this kind of project for you?
Definitely the day of competition. Day of competition. It's going in there and seeing it perform. It's just kind of like that moment where all your hard work pays off, and it's like, I actually did this.
Chloe Cease is a senior at Warrior Run High School in Turbitville, Pennsylvania. She's part of a growing pastime that brings math and science together in a competitive arena. battle robots. Robot competitions gained popularity with the BattleBots television program, launched in 2000. Today, students are involved in local, regional, and national bot competitions.
The whole idea of combative robots is not just the event. The event is fun, but the event is the end of the lesson. It's to test what you've built.
Kirk Marshall is a technology education teacher at Bloomsburg Area High School. He founded the Rage in the Cage competition in 2012 so that area teams could compete without the high cost of traveling to faraway competitions. He's witnessed the growth of the sport as well as the learning that takes place with the students that compete.
As soon as you throw that, like, hey, there's gonna be a trophy coming at the end, or you're gonna compete against somebody else, kids get excited. It doesn't really matter who you are. When kids see it as a reward to be smart, now we're rewarding the people that really deserve to be rewarded.
Now we're fighting! Robots, fight!
Combative robot is a robot that has offensive capabilities and defensive capabilities. In this particular case, all the robots weigh 15 pounds or less. And we want to basically inflict all our offensive capabilities into the other machine, whether that means lifting it up off its wheels or possibly hitting it hard enough that parts fly off. All of those are good things. And at the end of the match, which is 3 minutes long, judges either determine who is the most aggressive, the most strategy, and also the most destruction. And adding those scores up, they determine who's the winner. If you are lucky enough, you can knock the opponent out, and the match is over a little bit sooner, which is probably the best way of doing it, because you don't want to leave a decision up to judges. When I was a kid, before I'd throw something away, I would tear it apart and then throw the individual pieces away. I'd want to know what made this thing work. The kids don't necessarily have that skill anymore. They're not as involved in actively building and constructing items, sort of in the garage or in the basement. So you have to sort of like break down that boundary that they can do things.
Yeah, that was our spare. I made that to be a spare.
This robotics program really helps them in all academic areas, whether it be communicating, in math and science, because they are applying it while they're building the robot, while they're testing the robot, and pretty much all the way through. The hands-on learning and the problem-solving skills that they're picking up, it's second to none.
I didn't know how to use much of the machines back there, but now I do.
We had to pretty much take this entire bot apart, and we had to remake everything because it was all damaged and messed up from last year.
The first time we saw it do anything, it's got more power than I thought it did.
Yeah. Last year, the weapon didn't spin as fast. No,
it was a lot. Last year it was like 1 to 5 gear ratio, and now it's just 1 to 1, so it spins a lot faster, a lot more inertia, so it's looking a lot better than it did last year.
Warrior Run took sort of a leap of faith. And now they're 7 robots strong, and they're impressive. They're laying down the law out there, and that's cool. I recognize a lot of their faces, and when you see some of the kids competing and you realize that, hey, I saw them when she was a 6th grader, and now she's in high school, that's fun.
I would have to say, from experience, about 50% of it is your design and your actual bot. The other 50% is the actual driver and the maneuvering and everything. I mean, you can't go in there, you could have the best bot in the world, but if it just sits there in the center, it has its weaknesses. Every bot has a weakness, and if you can figure out how to exploit your opponent's weakness, you will win. It's all about strategy, being able to maneuver, being comfortable with your bot. You can't go in there and be afraid, oh, I don't want to do this, I could get torn up, I could get smashed. You just need to go in there 100% and hope you come out on top.
If you have a student that is really well versed in physics, they have a definite advantage in designing. So it is just a great opportunity to tie physics and the real world together.
It's interesting when they battle because you want to see whose design's best. But it does come down to the design and the physics behind the design.
Manufacturing is a passion for me because it really makes a difference in this country. It really is what builds playgrounds and communities. It is the individuals employed in manufacturing that make a difference. We also traditionally have higher wages and better benefits. It's a great career pathway, and most people don't understand those opportunities. The average American thinks manufacturing is really important. If they had 1,000 jobs come into their communities, they'd want those jobs to be manufacturing jobs. Yet 3 out of 10 parents would encourage their kids into careers in manufacturing. I think that really is at the root of the public perception problem. It's understanding that we first and foremost do still make things in this country. In fact, we make a lot of really great things. We make the cars you drive in and the airplanes that you fly and the medicines that save your life. So manufacturing really is centered on innovation and technology, and most people don't understand that.
Just look around, look at your clothing, look at everything that you touch on a daily basis. Whether it's plastic or metal, it's the production of every material object that you can think of. Someone is making these products.
Rick Hendricks has been teaching for over 25 years and has witnessed a major shift in the manufacturing industry.
The evolution of the manufacturing industry is really, it's beyond what you even imagine. When you talk about how we perceive manufacturing, I still think of those black and white wartime films where you see people on production lines and you see sparks flying at a foundry. And it was very dangerous. It was very unappealing. So now, most manufacturing environments are very clean, very well organized. The technology has just evolved, and along with that, the quality of work in the manufacturing sector has really improved.
I often hear what I refer to as the 3 Ds, dark, dirty, and dangerous. And when I talk to communities about manufacturing, I really talk about innovation and the 3 Ps. It's about the products we create, it's about the innovation in process that we use, and it's about the people.
The reduction in the workforce needed, obviously with the addition of technology, robotics, and all the automation has decreased that workforce in the unskilled labor area, but has kept the skilled labor demand up because we still need skilled people to program those machines and to set up the robots and to maintain them. So it's been a shift in skill to operate on the floor of manufacturing. In manufacturing, what has been changed in the last 30 years is the inventory buildup. We don't machine things and keep them in inventory. Inventory costs money. We have these concepts of lean manufacturing, where when a customer orders, we make it to their needs. So the evolution has been from making thousands of parts down to one and done. Skills needed to enter today's workforce in the manufacturing sector have really been scaled up. We need more skilled tradespeople in general. Doesn't matter whether it's if you're an electrician, in electronics, or mechanic, machine repair, machinist. We've seen such a reduction of unskilled labor. We've seen an increase in skilled labor demand due to the technology.
To be competitive in manufacturing today, you need to have team building skills and critical thinking. It's often the individuals on the front lines that make the biggest difference and the biggest decisions in a manufacturing facility. They're not just thinking about their frontline job, they're thinking about upstream and downstream. And it's that comprehensive approach to interdisciplinary workforce in manufacturing that's made manufacturing in this country competitive.
If you're in the machining and manufacturing world, you want to take courses such as chemistry and metallurgy if you can. Mathematics, you're working with geometry and trigonometry and basic algebra in our field, but even building up to that, the mathematics helps train your mind to be a troubleshooter and to be a better problem solver. So I think generally those technical science and mathematics courses are still vital in building a strong mind just to compete in this area. So the equipment, the technology, auxiliary equipment, your robotics, everything is just moving so rapidly. The SAE WVIA International competition is a worldwide competition of engineering schools throughout the country and throughout the world. And you have to be a member of the SAE, Society of Automotive Engineering. It's a total voluntary process. And you can be a welder, you can be a machinist, you can be industrial design. If you want to be part of this team, you can be. They design and build a car around a standard 10 horsepower Briggs & Stratton engine, which can't be modified. So we have to construct a frame, gearbox, transmission. There's specifications that you have to follow, a lot of them. This car is built entirely by the Penn College students, except for a few components. They bend the tubes, they weld the frame, they make the spindles, and it is a very time-consuming process. But this car, there's hundreds of hours of manufacturing as far as just machining the components. This car is built from the ground up, engineered through software such as SolidCAM and Inventor and Creo. We're testing the strength of certain materials. We're not just making parts, we're actually doing structural finite element analysis on the functionality, making sure things are going to work. You know, we learned that we have to cut some weight. The teams that are beating us have vehicles that are 50 pounds lighter, 75 pounds lighter than ours. We manufacture, we assemble, we disassemble. We test this thing out over and over again, and if something doesn't work, we fix it. This is part of the drive shaft in the car, and in the past we made this out of chromoly steel, and this year we machined them out of titanium and welded everything together. And now we have engineered a drive shaft that is not only about 2 pounds lighter, but also stronger. The Baja Club also built their own gear case. Now this gear case, we reduced the weight of this gear case from last year by about 4 pounds. And we also compacted it. And they machined every part of that gear case, everything you see except the bolts holding it together. These are some of the gears that go inside of it. These are made of 4140 steel that were heat treated. We took a new design that the students designed on SolidWorks. We produced a gear case that is capable of handling up to 40 horsepower. And now we only have 10 horsepower, but so we kind of over-engineered it in a smaller package. A machinist touches everything around you at some point in the manufacturing process. And this is This is manufacturing. This is what manufacturing is all about.
The Baja competition, some of my students are definitely involved with that, and they seem to just light up if you ask them in class, you know, have them relate something that they built. And that's hands-on learning, and they're designing and building something from scratch, basically, and then you get to see it come together and then compete. It's something that the students really seem to enjoy.
This is the Baja SAE Endurance Race. Teams compete in a variety of events over 3 days, but the endurance race is the final test of their design and engineering. For 4 hours, the car's speed, maneuverability, and strength are tested. And today, teams had to deal with some not-so-ideal track conditions.
First couple laps, I mean, you're just trying to get a feel for everything, find your position, and then after that, you just, you know, see how far you can push it without breaking it for 4 hours.
Once things sort of thin out, then you just need to start turning laps and pushing the car a little bit, and then the last parts, you know, the last half an hour or so, you got to stay out of trouble. That's like the home stretch, and you want to make sure, you know, your race doesn't end early.
It was just a matter of being aware of your surroundings, being aware of everyone, and sometimes you just had to bite your lip and take it slow throughout some obstacles in order to keep the car safe.
Our students have goals set in the races. They know they want to beat certain teams. They know they need a lighter car. They know they need a stronger axle.
The main difference between this year's car and last year's is that weight savings, you know, dropping like 60 pounds off of the car. And that made a huge difference.
The Penn College team finished in 5th place in the endurance race and 20th overall out of 107 competitors, their best finish ever.
Well, curiosity, well, I guess it's just a natural thing for me to be curious. So what they've done here, as a young child, my parents were somewhat upset with me because they'd give me a toy and I'd always take it apart. And it took me a few years to figure out how to put them back together. So it was a bit of a frustration for them. But it was my way of learning. My material science class, we start right at the ground floor, and then by the time they're done, they're looking at complex things like corrosion, the wear that happens in mechanical systems, and all relates back to the fundamental stuff we did the first few weeks. And so we try to apply it as much as we can. And experimentation doesn't always work. I mean, things fail, they mess up. And so you can't just sort of sit back and say, well, okay, I'm done with it, I'm not going to go further. You just need to be patient and continue to pursue those ideas and see how they lead and learn from those mistakes. Okay, so what we're looking at in a microscope today is far smaller. So I want them to be curious, even if they're not, and that natural curiosity, if it can be engendered in some way, increased, encouraged, probably will pay them dividends. Most people that get a job today are going to change careers 6 or 7 times, and a lot of that's due to the change of technology. So they need to keep building their skills, and you know, it's good to encourage students to say, take those risks. You know, if you go into a major that you just don't like, realize it's not the end of the world. That you can shift and move and make a different direction, and you learn from that. You say, I don't like to do those kind of things. Okay, I thought it was this, but it's not that, so now what? You know, and it's that next step. So it's the old, you know, journey of 1,000 miles begun with the first step, and you got to keep stepping.
What I want you to do is watch the screen. This first image is probably
Good, and now pull that down, this part here, and make sure it says PF. It's like the 4th or 5th choice.
I hope that this camp was sort of a spark moment for them, that they had a natural ability they didn't know about, and something like this camp set that spark off, and who knows what path that may take them.
Smart Girls is a summer camp program that was created to counter the academic and social trend of girls shying away from math and science as they enter adolescence and high school. The camp provides young females the opportunity to experience math and science as a foundation for careers in technology.
We're working through a book called What Color is Your Parachute for teens, and that helps them understand what their skill sets are, what their passions are, what kind of work environment they would like to be in when they become adults. And then the other side of that is the Carnegie Science Center Mobile Fab Lab is here on campus, and they are working through designing and building their drones or quadcopters.
It should be at a diagonal, so you should see a V on a diagonal.
Okay, so it doesn't matter which side it is?
No,
okay.
No, you're cool.
So we recognize that girls that are entering middle school tend to shy away from math and sciences and even technologies and engineering. And the ramifications are that they end up in job positions that are maybe not at the level that they could be working at. They're not having the impact on society that they could be having, and even their personal life. They could be living, at a higher level. And so we find that it's very important to show them that it's important and that it's fun and that it's a world that they can live in.
I'm really interested in possibly some engineering career, so I thought it was a really good camp for me. And I'm a math and science person, so.
I want to be a software developer somewhere in computer science engineering.
I learned more about engineering and stuff, and I learned that it's actually really fun. I really liked designing the frame of the copter, and then the laser cutter was really cool to see it work.
Rotate them. You will be surprised at the amount of airflow that you'll actually pass down through those.
Out of all of the different camps and project workshops and engineering challenges that we run, this is without a doubt the capstone and the most difficult one.
So there it is. Go back and give it a shot, see what you think.
I think a lot of them were really good with the CAD design. They can grasp the computer component, they can get the parts installed, follow the schematics that I gave them and how to build this thing, and then when they actually fire it up, they're sort of amazed at how difficult this actually is to fly. And I demonstrate for them, here's what a quadcopter does, and they think oh, he must have just done that, that's amazing. And I tell them, I've been doing this for a year and a half, it's not that easy.
It looked really easy since I play video games a lot, so I'm used to controllers, but this controller was really different from the controllers I use. So there was a lot of walking back and forth between the flying room and the fixing your drone room.
The campers' designs and flying abilities are put to the test on the final day of the camp. With family members in attendance, the girls must fly their quadcopters to 4 separate spots in a timed competition. They are also graded on their copter's functionality, appearance, and perseverance. And for the confident pilots, there's a bonus challenge.
That cultural thing of females aren't doing engineering, they aren't doing mathematics, to me it's just ridiculous. There were a handful of students who told me I've never done this before, and I'm watching them build, and then they're zipping and flying around. I'm I know they are naturally inclined to do this. And if they just ignore those cultural norms or whatever they should be doing or anything like that, they're going to be doing what they're supposed to be doing, which is designing machinery, doing biomechanical engineering, doing mechanical engineering, computer, electronic, because male or female, everybody has that innate ability to do something. And if it's this and the girls get pushed out of it, it's just a shame, it's a waste.
plastics industry's everywhere. If you go through your daily life, whether it's aerospace, automotive, packaging, electronics, everything has plastic components to it. And at some point, someone has to dream up those plastic parts, design them, take them into manufacturing, build molds for them. Every new innovation has something plastic, so it just infiltrates every portion of our lives.
Tim Weston developed the curriculum for the Penn College Plastics program in the 1980s to fill a need in the growing plastics industry. He then became the program's first instructor.
Industry was a real important part of what we did back then. Industry is a big part of what we do now. Eventually they said, hey, you're doing a great job with the 2-year program, how about a 4-year program? Eventually they said we need help with projects and training, so we built something that is now the Plastics Innovation and Resource Center. A lot of that was driven by industry, and they said, here's our ideal employee. And that ideal employee is able to think through problems and be a problem solver.
Remember, pitch goes from front to front.
To do that, sometimes you have to have some hands-on skills. You have to be able to roll up your sleeves and go do it to be a problem solver. Sometimes that requires a little bit of math. Sometimes that requires a little bit of science. But you really have to know how things work. And that's really all math and science are, is, how do things work?
We are at Pennsylvania College of Technology. We're sitting in the extrusion lab, the plastics department, and we're talking with members of the faculty.
Plastics is the 3rd largest manufacturing industry in the country. Most people don't realize that just because they see plastic everywhere, but think of industries like the automotive or electronics, consumer products, toys, those kinds of things, and don't realize that there's an industry behind that that's manufacturing these products.
Plastics, traditionally, as we think of them, were created in the late 1800s, but the industry really took off during and shortly after World War II. So, you think about the scope of other industries, steel and other things that have been around quite a while. Plastics is still in its infancy. And the other cool thing about plastics is it's so broad. There's so many different types of plastics and so many different applications for using them. Where I see the industry heading is utilizing things like 3D printing to help get other products to market fast. Historically, in industries like automotive, the process from concept into getting into production has taken quite a while, years in fact. I think that customers are wanting things faster and faster and faster, and they want it with better quality. So that's where I see the industry heading, and I think having a degree in plastics engineering technology can help you because somebody's got to be making these decisions and innovating and figuring out how to make that happen.
I have the honor of teaching our sustainable materials class, and in that class we talk about what is the green movement, what types of myths and truths there are to the plastics industry. The greening of the industry is essentially kind of what's happened with all the industries as they've begun to grow. So the beginning of steam power, metal, all of that, all of the industrial evolution essentially, with all of their emissions they made over the years, bring that down. So since the plastics industry is so young, we're kind of reaching that industrial revolution where we're kind of starting to realize, hey, maybe we shouldn't make all these parts if we don't have a way to recycle them or do something with them besides putting them in a landfill.
as designers and engineers, we can think about the behavior of what people are going to do and say, okay, I'm going to make the smallest impact possible because I'm going to design this part that when they're done, they can just take it, put it right in one bin, it goes into a machine and gets recycled easily. So, we try to kind of teach that philosophy that don't just think about how do you take the pellets and make the part, what happens when that part's life is over.
People will say, can you make it more recyclable? Can you make it a more sustainable sourced material? And I always tell them there is no one on the planet that has a bigger vested interest in doing that than the plastics industry. We care because it is what we do. We frequently tell students who are looking at the program, you're the one who's going to provide that solution. If you want to do something that is good for the environment, is kind to the environment, jump on board and figure what that solution is.
I attribute a lot of my passion for math and science to one, having really great teachers through elementary and middle school that really instilled that passion for math and science, but also just from personal standpoint, Legos are great for just people who can conceptualize with their mind and their hands, just to build things and kind of see how they work.
Fire Tree Place, a youth community center in Williamsport, Pennsylvania, strives to build stronger communities through education, recreation, art, and social programs. These elementary and middle school students are participating in the Lego Magic Club. Using Legos as learning tools, the students' creative thinking and problem-solving skills are challenged through a hands-on activity that also teaches basic computer and coding skills.
And tell me when to stop. Now, 27. I changed these when it was 2, because this one is faster when it's 2.
The goal of the program is to expose students to STEM activities in an engaging and fun way.
Well, we made a sweeper. I learned that putting this gear in the front, it makes it a lot faster, but if this in the front, it's going to be way slower. So this gear is most important.
When they're young, the students love science. And I think because these teachers make it so hands-on, and they make it so relative, and they make it so the students get dirty and they get involved with the science. And then they talk about some of the concepts after the students get involved with it. The elementary school teachers have it right. And then things start to change, and the curriculum changes where you've got to shove this content at them, and you got to make them use the math in order to understand it. And the passion for learning the science is gone because the students don't see the relevance of it.
A great way to completely turn off a room is to say, hey, we're going to talk about chemistry. But I've had the experience of being in a classroom and trying to explain what is happening to individual molecules, explaining to the students what's happening with this polymer chain at the molecular level, and see them almost begin to smile as they realize, I see how that connects to what's happening as that bottle's being blown. So the students that get that, they're so far ahead, they're leaps and bounds ahead, and they begin to be able to innovate from there when they start to have the opportunities and the freedom when they get out in industry.
My name is Kelly Butzler. I teach general chemistry, organic chemistry, forensic science, and a chemistry and society class. I sit and I talk about basic concepts in chemistry. And students try to seem interested for my sake, to humor me, but I can tell that they're very, very bored. So when I bring in real life examples, you can see they stop and they look and they perk up, and then they start asking me more questions. Chemistry is a broad scientific field. Its relevance is in almost every aspect of manufacturing, particularly in plastics and materials manufacturing, pharmaceutical. It even goes into your cooking, basic everyday life. And I try to bring that into the classroom when I can. But where's 295? Students always ask me, why do you teach chemistry? And when I was in high school, I took biology, loved biology because it's relevant and you can pick things up and you can see it and you can touch it and you can interact with it every day. And then I took a chemistry class and it wasn't as exciting for me, but then we did a whole month on qualitative analysis, and we weren't lectured to. It was all hands-on experience, and it was so much fun, and I loved it, and I loved that it was almost like a puzzle. Like, what is this unknown? Let's figure out tests to run the unknown, and I really loved it. And you're gonna, on the filter paper. I stress in my classes the scientific method. I try to remind them that questioning and then doing experiments to see if your question was correct or your hypothesis was correct is the foundation. And through the process, I teach them, what did you do? What are your observations? What are the results from that observation? Like I constantly keep asking them that, and I keep asking them to write it down. And I'm hoping by doing that, that when they go into the lab, whether it's manufacturing lab or when they become seniors or do an internship, they remember that process that we went through, that they can start putting things together and seeing what happens, but they've got to be really, really careful in making their observations and recording those observations.
So we're making our slime.
This is Kelly's daughter, Kate, and her friend, Reese.
My daughter, she loves making slime. She's got a clandestine slime lab in her room. She thinks it's like the most interesting thing. She's seeing mixtures of things and what is the outcome they're playing, and it's pretty neat.
First, you gotta make your activator, which is borax. It's 1 cup to 1 tablespoon. We're mixing the borax powder with the hot water.
Usually your main ingredient's glue, and then you need an activator, and you can add in like shaving foam.
It was on my recommendation on YouTube, so I watched it. I'm like, this is so stupid. Why would anyone want to make this? And then I was like, I watched more YouTube videos, and I'm like, oh my gosh, I want to make this. I didn't know how to make it, so then I watched more YouTube videos and then asked my dad for glue. And you're gonna take your glue, and I'm going to pour that in. I'm gonna make my glossy slime.
I guess I'll make fluffy slime first.
And then you're gonna mix it, and then I'm going to activate it. So then you're gonna take your borax and mix.
I'm now gonna put it in shaving foam.
And then you're gonna knead it. I know, it looks like a mess right now. This is the stressful part.
I'm gonna add in some food coloring. I think I'm gonna make mine purple.
It's now like getting more like formed into slime now. This has PVA, and then the borax has some sort of chemical that reacts with the PVA. Should we rate our slimes? Like, okay.
So it actually feels really nice.
I like yours, but like you overactivated a little bit.
I overactivated. Yeah, and usually when you let it like set in the container for a while, it usually gets better.
Yeah. Overall, I'll give this a 7 out of 10.
I really like this one. I'd probably give this like a 9. Thank you.
I'm definitely going into something with STEM. Science, technology, engineering, and math. I want to go something in that. I think science, because I love science. Science is probably one of my favorite subjects. And bam, you got your slime.
I had 2 older siblings that inspired me a lot. My brother was a tinkerer and he liked to take things apart and put them back together. And I remember as a young child watching him and being like, wow, you can take things apart like that and find out how it works. But also, my earliest memories probably go back to the Apollo missions and sitting around the TV and watching the moon landings. I remember that vividly with my family. And even up through high school, my sister and I would sit and watch the shuttle launches and thinking, wow, that is just awesome. You know, you can go into space. And those things inspired me a lot when I was younger. But then as I progressed through high school and in college, I got into the math and the science more, and I liked to know how things work, and it explained how nature worked, and I had some really good professors. So I went through a progression of different topics and different subjects that interested me. But I remember as a younger child liking to build things and hands-on, and as I got older, I liked the more theoretical side of things. The educational data shows that students learn by doing, and the science side of things, there's so much that they can do that making that connection is letting them discover for themselves rather than telling them exactly what they should know. I love the student that says, I want to know how that works, you know. That's the most rewarding part of teaching, is to see the students, you know, take the physics and apply it to their major. We're always transforming ourselves and shifting ourselves from one thing to another, but we're still the same person. You learn a lot more by expressing your ideas and working together with fellow students or teachers. And so combining that with the science, the technology, the hands-on, and the competitive nature, along with the teamwork, it's something that really, I think, will bring students and interest students in the sciences and the technology.
I don't know where it comes from. It could just be cultural, or it could be part of, you know, this, us as a nation sort of has this weird expectation of perfection from the get-go. Whether it's social media or whatever it might be, that you see this perfect veneer. The amount of work that it took to get to that perfect veneer is not often talked about. So I hope the girls could take that and not only apply it to STEM classes they may take in high school or college or beyond, but they can apply that to other areas of their life as well, that initial failures don't need to be the end all. Learn from it and move on.
The skills that these students take away with them are extra learning skills that they've gained outside of the classroom.
If you want to be successful, be a nerd, be smart. But it's going to require some effort. You know, it's going to require taking the difficult classes. It's going to require failing sometimes, because failure is really the best way to learn.
If you give the kid that tool of education, or that tool of knowing how you can find things, that's what they need. They need that push across the bridge. And once they've gotten on that bridge and they're walking on their own way, they can take the rest of their life on their own.
Keep pushing yourself and try to understand the basic components of how things work. And eventually, it depends on your path in life, but eventually you'll get those answers.